Write that, you get an exception because you cannot make a network request on the main thread. Easy, we just put it inside a thread and run the code. Now you're going to complain is the text view, which is like you cannot touch the UI thread from a background thread. And OK, we'll write this kind of code where you make it asynchronous, you provide a callback, it runs on the background thread and calls your callback on the UI thread. And this code works fine. Except if you're writing code like this, you're going to receive out-of-memory exceptions because you're going to be leaking those callbacks left and right. There's a solution to this as well, where we can have an understanding of a subscription that keeps this chain, and whenever UI is stopped, we can just cancel the subscription. That one works, but then you end up something like this. And I'm not making this up, by the way. 3 years ago, when we started architecture components, I was looking at the Google app codes, and I found one application that had 26 lines of event bus unregistered. So if it happens at Google, it happens everywhere. We don't always write the best code. But there's a solution to this as well, which if you're using something like RxJava, and so this function returns an observable, you can just use the auto-dispose library, associate that subscription with your view lifecycle, and safely subscribe. And this works perfectly. Similarly, you could be using live data, which enforces you to have a lifecycle to observe, and this also works. So it's just
requests 3 ways. The first style is what's called a blocking style. This is where the result is returned directly from the function. Let's see how that executes. And for fun, I'm going to run that on the main thread. When called, a blocking network call will block the thread that called it, so the entire time that network request is running, the main thread will be blocked. And that's the thread that has to update the UI and handle user touches, so the user will see your app is frozen, or it might even crash. Now, I do want to pause and say there's nothing wrong with a blocking style of network APIs, but it's not what we want to do on Android. So to fix that, as you'd already talked about, we commonly introduce callbacks. So let's see how that executes. We're still going to call this from the main thread. But now, when fetch user is called, the main thread is free to perform other work. It can handle on-draw or respond to user touches. And the networking library is responsible for finding another thread to actually run the request. When the result is ready, the network library can then use the callback I gave it to call back into my code and let me know that it's ready. Let's rewrite that exact same code with coroutines. It looks just like the blocking style. The result of fetch user is available immediately, and I don't have to introduce a callback. To tell Kotlin I want to execute this with coroutines, it has a suspend modifier on the function. And when we run it, still on the main thread, the main thread is unblocked just like with callbacks. And this is a key concept of coroutines. The networking request still runs on another thread. When the result is ready, it resumes the coroutine where it left off. This code is much simpler than the callback style, while still ensuring that I can write my Android app and make it never freeze for the user. This is the key mechanism here of coroutines: suspend and resume. When a coroutine is suspended, it's not running, it's paused. And when it resumes, it picks up from where it left off. You can think of suspending a coroutine as taking a callback from the rest of the function. So you've put it together: suspend and resume replace callbacks. We can even visualize that. The callback version and the coroutine version execute almost exactly the same way. Let's switch back and take a look at fetch user. How can we call a function that makes a network request from the main thread? To start, we'll need to make fetch user another suspending function. This tells Kotlin that it works with coroutines, and inside, we'll call another suspending function called withContext. We'll pass it dispatchers.io. Zooming in on those dispatchers, Kotlin gives us 3 dispatchers: default, IO, and main, and they're used for different things. Default should be used for CPU-intensive work, things like transforming a list of 100 elements, calling diffutil, or pre-computing text. Anything that takes too long to run on the main thread should run on the default dispatcher. IO is a dispatcher that's optimized for blocking network and disk IO. You should use it anytime you need to write code that blocks an API, like writing a file or reading from a socket. And main. This is the main thread on Android. And surprisingly, it's our recommendation as the right place to start coroutines in response to UI events. Since you're usually starting
Of new APIs that we just made.
Thanks, Sergey. So far, we talked about what you could do with coroutines. And for the rest part of this talk, we are going to talk about new stuff. So first one is live data and coroutines. Now, just to be very clear, live data is not designed for concurrency. It's an observable value holder, and you are expected to be able to access the value from the main thread. That's like intentional. But that doesn't mean it should not be interoperable. So this is what we are going to provide you today. There will be an easy way to use live data with coroutines. So the most common use case is you have some value you want to compute in a coroutine, but want to serve the result as a live data. So starting today with the Lifecycles 2.2 Alpha 1 artifact, you get this new API called live data. So it's a builder function very similar to the sequence builders in Kotlin. Inside that, you pass a coroutine block, and inside you can do whatever you want and call this emit function to dispatch values. So if you look at this database load function, it is actually a suspend function. And because you are calling the emit with the user in this case, we can infer that type for you. So you don't even need to specify this. So this very simple live data API bridges the gap between your live data elements and your coroutines. So let's look at that API a little bit more in detail. So it receives 3 parameters, and the first one is a context. So why do we need a context? Well, if this database load user function wasn't a suspend function, but it's a regular function, and you write this code, you are going to receive an IO on main thread exception, because this block by default runs on dispatcher's main. But we can change that. We can tell it, give it a context as dispatcher's IO, and now this code will work perfectly. I want you to notice that I didn't change any contents of the code because you can emit from whatever dispatcher you want. You don't need to be on the main dispatcher to change the value. Now, the second one is a really awkward parameter called timeout. And to understand why we needed a timeout parameter, let's look at the infamous rotation problem on Android. So on the left, I have a view model that serves a live data, and on the right, I have an activity that's observing it. So when my activity goes to started state, the live data will become active, which means, okay, you have an observer visible to the user, you are better off creating some values. But during that time, what if our activity rotates? So it's going to be stopped, live data will become inactive, be destroyed, and a new activity will come. So right now, there is no one observing live data, so there is no reason to produce results, except after the new one goes started again, it becomes active again. So the problem we are trying to solve here is this gap where live data quickly becomes inactive and active in a very quick succession, like usually less than 1 second. So how do we fix that? Let's look at the detail how we'll run that code block. And to understand it better, we're just going to write a timer function. It basically creates a timer of a live data. It gets the current time, returns a live data builder, and in an infinite loop, it just emits the time, delays 1 second, emits the time, delays 1 second, and never ends. And this code I'm showing is 100% OK to write. So how does that actually work? When the live data returned by this block becomes active, we check, OK, did we run this block? And if we didn't run that block, now we start executing it. While we're executing it, if that block becomes inactive, like if the live data becomes inactive, we check, OK, is this block still running? And if it is still running, we give it some time to finish. But even after the timeout, if it is still running and we are inactive, that's basically unnecessary computation. There is no one observing the live data, but the block keeps running. So we just cancel the continuation, the coroutine. So if the live data becomes active again, we're just going to restart it. And we only do it once. So if it finished the completion, there is no reason to restart it. Now, you can also emit more than one value. So let's put some structure around the sample we had before, where we have a repository that has a get user function, a load user function, and a loads from the database and emits that value. Now, most of the time, this is not the code you write. You need to go to the web service, fetch an updated user, update the database, and emit that value again. So you can call emit as many times as you want, as long as you are inside that coroutine block. But you might say, well, most of the time the database doesn't return you a user. It returns you a live data for user because you want to be notified about the changes. Well, all you can say is you can just call emit source. If you ever use mediator live data, this is very similar to add source, where it says whatever value comes from this live data, just make it my value. And you can run things like transformations here. Oh, also, now we don't need this extra emit because we're already observing the database, so you can get rid of it. So this live data API basically provides us a very nice way to make live data work with coroutines. But how about view models?
Thanks, Yi. So let's talk a little bit about how to integrate coroutines into your view models. But first, I want to talk a little bit about leaks, specifically coroutine leaks. And these are a very serious problem. They're kind of like a memory leak that we're all familiar with, but way worse. A coroutine can resume itself, and in addition to using memory, it can use CPU, it could write a file, it could make a network request that doesn't need to happen. To help us deal with coroutine leaks, Kotlin introduced this idea of coroutine scopes. So what is a scope? Well, it's really just a way of keeping track of your coroutines. All coroutines must run in a scope, and a scope gets the ability to cancel all of the coroutines inside of it. In addition, they're also the place that uncaught exceptions from a coroutine get shuffled off to. And you put that all together, and you can use scopes to help ensure that you never leak a coroutine. Work Manager that Sergey talked about provides a scope. So does the Live Data Builder that Yeet just talked about. ViewModel scope is a scope. It's an extension property on ViewModel from the KTX library. I'm going to do another one of those scary infinite loop things that Yeet showed, but this time in a coroutine that I start myself in a ViewModel. It uses ViewModel scope to launch a coroutine in the scope, and by default, this launches on main. Then it starts an infinite loop that doesn't know how to stop itself. And every second, it's going to go ahead and write a file. Now, that's pretty expensive. Coroutines don't make writing files faster or cheaper, and we definitely don't want to leak this work. ViewModel scope lets us write code like this safely. When the user navigates away from the screen, the scope will be canceled, which guarantees this very expensive work won't leak. So ViewModel scope can help you avoid coroutine leaks by guaranteeing all your coroutines are canceled whenever a user leaves the screen. I'm going to pass it over to Sergey, who's going to talk about some other scopes we're adding.
Yeah, thanks, Sean. Yep. Another thing that very naturally provides scope is lifecycle, because as you can say from its name, something that has a start and the end. And if you think you are not familiar with this lifecycle owner interface, you actually are, because it is your activity, it is your fragment, and don't forget that fragment conveniently has two different life cycles, and the second one is associated with views inside of it. And fortunately for me, I don't have to talk about that. But let's define the scope more precisely. So as you know, your fragments are get recreated over do configuration changes, so its lifetime can be shorter, it can be longer, and lifecycle scope just mirrors that. Meaning that once your lifecycle owner receives destroy event, lifecycle scope gets canceled. And all its inner jobs are canceled as well. So as you can see, the lifecycle scope is very tightly coupled with UI, and it works best in situations like that. So previously, you do something like this when you decide to show some UI with delay. And well, this looks pretty simple, so we can make it a bit harder. And if we have it 2 steps, it becomes to look very ugly because of this deep nesting. And actually, if you take a closer look, you have some real issues here, because this main handler and those functions that touch UI don't really work nicely together, because main handler is kind of a global scope. It doesn't care about your lifecycle at all. And those functions have reference to fragments or activities. So if your delay is long enough, you can easily leak a lot of them and receive out-of-memory exception. While lifecycle scope will cancel those callbacks that are show full hint for us. Is a kind of a callback because it's a suspend function. It will cancel it automatically once your lifecycle is destroyed. So this code looks nicely because it's very sequential and is actually safer. However, I have to say that lifecycle scope is a bit of a danger zone. So let's rewind a little bit. I was the one who showed you that retrofit and room supports suspend functions. Each showed you something that very familiar looks like that. When you say, OK, I will combine those functions to network and database into some repository pattern, and I will have just one function, which is suspend function, that orchestrate all of this work. So I just need the scope to call it. So why wouldn't I just call it in my lifecycle scope? And it's actually not the brightest idea. Well, why? And don't get me wrong, Eat and Sean told you everything correctly. It won't block main thread. It won't leak coroutines. However, do you remember this picture? Lifecycle scope gets canceled on every configuration change, meaning that your network request gets canceled every time. So it is just wasteful. You're wasting user resources, battery resources. It's just bad for environment. So, how you would do it properly? Well, one of the things actually was presented by Git. Like this live data builder will work very nicely in these kind of situations. I'll present you like in our way how you can approach this. So your starting point for this kind of task is a viewModel scope. So you just run this load node function in this viewModel scope. Then we introduce a function in viewModel that will connect our UI in a viewModel, where when you grab a node. Well, as discussed, it's a network call somewhere inside of this load node. So it's asynchronous operation. So it should be suspended. And well, now we need to somehow connect this node that is loaded in one scope and load node function that will be called in some other scope. Well, I will use complete deferrable. Well, it sounds a bit scary, but it's actually a very simple thing. You will see in a second. So how we use it? We complete our deferred with a node that we loaded. It just put the node into this object. Nothing happens. And readers request the node, like with a wait function, from this deferred. If a node isn't ready yet, then the reader will be suspended. If it is ready, reader will resume right away. So this is how we implemented our viewModel. And last step, we just call that in our lifecycle scope, this load node function that we introduced in the viewModel. And our network call is properly executed in viewModel scope, so it's not affected by configuration changes. And our update UI function doesn't leak once your lifecycle owner gets destroyed. However, once we add a fragment into the picture, things get complicated, as always. So we decide to run the fragment transaction, and you will get a legal state exception because nothing guarantees you that you are in the correct state that allows you to execute fragment transaction. And we did something smart and introduced some special function that help you to deal with these kind of situations. And this is going to be a bit tricky because it's actually fairly complicated thing. But what it does, this block will run only when your application is started or resumed, meaning that it's in the foreground. And this block will be suspended when the application is, when your lifecycle is just created. So let's take a look on an example of what it actually means. So you have this function. It is called. Probably in the beginning, your block will be suspended because node is not ready. Then, once it is ready, in usual situation, we would resume execution and proceed to the next line. But with launch when started function, we're going to go and check lifecycle. If it is not started, we're going to suspend further until the lifecycle will become started again. And once it is started, when we're going to proceed to the next line and execute this transaction, so we won't run into this exception situation. So one thing I want to highlight that this block is suspended during creation, and it's a different thing from being cancelled, because cancellation is still provided by lifecycle scope when destroy event happened. And now, as you can see, it's something that we definitely need to test, and Sean will help you with that.
Thanks, Sergey. So we talked to you a lot about coroutines today. We talked about how they can help clean up APIs by replacing callbacks with suspend and resume. We talked about different ways they can be used in different situations. And that's all great. That's awesome. But if they were difficult to test, that would just be a non-starter. It wouldn't be something that I would take very seriously as a thing to use. So what I want to talk to you about right now is Kotlin X coroutine test. It's a new library. It came out about a week and a half ago. That's currently marked experimental coroutines API because it needs more feedback before it makes it all the way to the stable. It's a collaboration between Google and JetBrains to make testing coroutines on Android very easy. So it's not coupled to any testing libraries. So you can use JUnit 4, you can use JUnit 5, you can use your own custom test runner that you've built, and this library is going to help you test coroutines. So I'm going to focus in on that live data builder that Yeet showed, and we're going to talk about how to write a test for that. So I'm just going to emit 1, I'm going to wait a second, and then I'm going to emit 2. So this is a relatively simple live data, so I can focus in on how to write the test for it. So to get started,
the view is destroyed, and a new instance of the view appears. It subscribes again to the live data, and the view model doesn't know what just happened. The view model doesn't even have a reference to the view, it just exposes data. So why are we talking about this? Whenever you do an operation, and an operation can be something like fetching data from the network, preparing some text, you have to choose the scope of this operation. This means when this operation is going to cancel. If you cancel too late, then you might be wasting the user resources. If you cancel it too soon, you might have to restart your operation. But in a real-world app, and this is the Android Dev Summit app, we have way more scopes than that. For example, we have a schedule screen with potentially multiple instances of the fragment schedule, the view model that is scoped to the screen, the agenda, the info screen with fragments and view model as well. Then we have a main activity and a view model that is scoped to this activity. And then you can even have custom scopes. With the navigation component, for example, you can create a scope for a login flow or for a checkout flow. And then we even have the application scope, which is a special case we'll talk about later. So there's going to be a lot of operations happening at the same time, and we have to manage the cancellation somehow. We need a way to find something that helps us structure this.
Make an introduction to Kotlin coroutines, but want to talk about why we like it for this particular use case of Android development.
Initial value of that flow is, and then at the end, we just convert to live data. And this is where flow really shines. Normally, you want to do a transformation on each item that you are observing or that you are receiving. If we do this with live data, then you might want to try map first, but this would be main thread, and it would be awkward to use a coroutine from here. So it's much better that we use swiftmap, and we return live data created with the builder, And because we are in a coroutine context, we can call this heavy transformation function, which would be a suspend function, and emit its result. With flow, this is much, much better. We just call map on the flow. And because we are in a coroutine context, we can call the suspend function. And at the end, we just convert to live data.
All right, so how do we use the suspend functions and flow library in our repositories? Now, repositories usually where you have a lot of custom code, like you're making APIs, collecting data, filtering, whatever business logic you have. In these cases, you may want to do a lot of transformations. And as Jose mentioned, like we never intended live data to do these things. Luckily, with Flow, you have all these operators on your streams that you can use. So just go ahead and use Flow or suspend functions in repositories. Similarly, for your data sources, suspend functions and Flow are great fit. But here, things get a little bit more trickier because this is usually the part of your code where you're talking to other libraries, remote sources, whatnot, so you don't control all of it. So let's look at all those cases, see how we can integrate them. The first case, the best case, is you have one-shot operation. So you have one-shot operation to get some value, like let's say from a network request. So if you're using retrofit, just mark the function as suspend, and you're done. Retrofit already supports suspend functions since version 2.6. Similarly, if you're using Room for your database, since version 2.1, it supports suspend functions. So you tell it to return a suspend function, done. You don't need to care about it anymore. But if you're dealing with a library that's not updated for the coroutines world, maybe it's a Java library and it has callbacks, sounds super old, callbacks, now you need to do some work. For those cases, we have this thing called suspend cancelable coroutine builder. This thing is basically the adapter between the coroutines world and the callback-based world. What you do is when you call this function, it gives you a continuation that you are responsible to call. So we make our API request. If the API gives us a value, we resume the continuation. Or if the API tells that an error happened, we resume the continuation with an exception. This is all you have to do. Once you do this, rest of the coroutine machinery works, and you can abstract this somewhere outside of your code. Notice that if you happen to call this continuation much later, like after it's canceled, it's just ignored. And you can also change this code a little bit better so that if the coroutine is canceled, you can eagerly cancel your API request. Now, the third case is where you have a lot of values, like you want to emit multiple values. And Flow Builder is a great thing. It's very similar to the Live Data Builder, except you build a flow, and you can emit values. So we have an example here that like infinitely every 2 seconds dispatches a new weather value. It's also super handy when you're writing tests, actually. Just like say, oh, this is this other flow. But if you are working with an old library again that doesn't support flow and like is a callback, you can use this callback flow builder. It's very similar to the previous one we saw. So let's say we have an imaginary API here that receives an imaginary callback, and that callback has 3 functions. It's like next value, on error, and on completed. We register that callback with our imaginary API, and every time we receive one of those callbacks, we just say, OK, offer that value. If a new value came, offer it to the flow. Or an error happened, basically close the flow with this error. Or if it closes nicely, the same way close the flow. Now, you need to be careful here, because this callback flow builder, once it returns, flow is closed, so you cannot dispatch values to it anymore. We don't want it to return. So for those cases, we have this thing called function called await close, which basically suspends until the flow is not collected anymore. There might be any reason you close it here, or maybe the collector just stopped collecting. And in that case, we simply unregister from our API.